In this presentation, we're going to be talking about structured programming and how it differs from the programming you've been doing so far. So far, you've been programming statement after statement after statement, as we see here in a sequence. Now, you simply go on to the next statement after you finish this current statement, and that's a sequence of statements. We're going to now look at two different ways of changing the order in which the statements are executed. One is to look at a selection where you can ask a question, have it go one way or the other based on the answer, and after it finishes those two different paths, join up and do something after that. The other way we're going to change the order in which statements are executed is to look at an iteration. An iteration starts doing something. Usually it does a test there to see if it should continue or stop. If it says continue, it goes and does something inside the loop, because these iterations become loops. Then it goes back to the beginning and checks to see if it should do the body again. And it does that until eventually the decision is it should stop the loop, at which point it goes on to the next statement after the end of a loop. So iteration takes advantage of the fact that computers are very good at doing the same thing again and again really fast. Selection allows us to make decisions and change what we do in response to some condition. All of our structured concepts should have one entry point and one exit point. So we know that a program consists of a series of structured constructs, and we're going to be looking at what a structured concept is. Every construct has a single entry point and a single exit point. And the advantage of that is, first of all, it's easy to read because you don't have to look to see if there's multiple exit points. But it also means that you can replace the internals of one of these constructs with another internal, and you don't have to change anything around it because it just has one entry and one exit, and nobody cares how it works internally. So that makes maintaining your program a lot easier. Now let's take a look at code blocks. A sequence is the simplest way of arranging a program. It is a series of statements one after another. The very simplest sequence we can have is a single statement, but you can have multiple statements. Now, any place you can have a statement, you can replace it with a code block. And a code block is an open curly brace with a closing curly brace, and in there, one or more statements. And anytime you have the language looking for a statement, it can have a code block instead. So code blocks are really the equivalent of statements, except they contain multiple statements. When we're writing programs, one of the ways to get our ideas down before we actually code them is to write pseudocode. And pseudocode is English-like statements that say what the steps are to solve the problem. So for an example, we looked at how to calculate the radius of a circle in one of our previous examples. So we did it by reading the radius of a circle, calculating the area as radius times pi, and finally printing the area. And that allowed us to calculate the area of a circle. Well, this, writing it down in English, is the idea of pseudocode, getting your ideas of what you have to do down. Another way of getting your ideas down is to show it diagrammatically as a flowchart. So here we get the problem that the lamp doesn't work. So we ask a question, is the lamp plugged in? No, plug it in. Yes, is the bulb burned out? Yes, replace bulb. No, send the lamp in for repair. So this is showing you the steps and decisions you have to make to determine why your lamp isn't working. And it's done as a flowchart or a diagram like this. Now we want to look at the different types of conditional sequences, and we have three that we're going to look at. We're going to start with the diagrams, and then we're going to look at the code for them. First one is an optional sequence, and it comes in, and in this diamond shape, we ask a question, which is called the condition. And it's either true or false. If it's true, it goes and executes a sequence, which could be a single statement, or it could be a code block containing multiple statements. If it's false, it skips the sequence and goes on to the next thing after the whole conditional sequence. The next one is an alternative sequence where it comes in, it asks the question for the condition. If it's true, it does this sequence of statements. If it's false, it does this sequence, and after it has done one of those, it goes on to the next thing in the program. The third thing is called a conditional expression, and this is a way of kind of putting an if inside an expression, and I'll show you an example later. But you come in, you ask a question. If it's true, you evaluate one expression and return the result. If it's false, you evaluate another expression and return the result. That'll become more obvious when we see it in code. Now, here's an example of what an if statement looks like. If, and the condition is A equals 10. So that's asking the question, is A equal to 10? If it is, it's going to come in here and execute the body of this code block, which has got one statement in it, and it says printf A is 10. So that is your if. The next one is the if-else statement, which is the two alternatives. And it says if A equals 10, then it does the first block and prints out A is 10, else it does the second block. So if A is not 10, it's going to do the second block and it's going to print out A is not 10. The third one is a conditional expression, and it's a bit strange. So I start out and I say int A equals 12 and limit. And I say limit equals A is greater than 10, question mark, 50:0. Now the way you read that is if A is greater than 10, the answer is 50, otherwise the answer is 0. So if this evaluates to true, then it picks the first expression. If it evaluates to false, it picks the second expression, and that is the value assigned to limit. So it evaluates some expression, and then based on whether it's true or false, it returns either 50 or 0, and those 50 or 0 could be entire expressions which need to be evaluated themselves. It evaluates one of those and assigns the result to limit. So it's kind of like having an if right in an expression on a single line without having to write multiple lines for an if statement. We can put multiple ifs together to create a multiple selection. So I can say if A is greater than 0, we print A is negative, or if A is less than 0, print A is negative. Else, if. So it's an else, but it's followed by a single statement, which happens to be an if. And it says if A is greater than 0, printf A is positive, else, followed by a single statement, which in this case is a block, printf A is 0. And we can go through and do multiple comparisons by combining multiple ifs. Another way of doing a multi-way decision is with a switch statement. And switch statements only work with integral values. So here we've got switch based on the value of n. If n equals 0, it executes this and it printf 0\n and breaks. If n is 1 or -1, it's going to print out 1 and break. Now that break causes it to go to the end of the switch statement. Here we've got a case with no break, which means that it executes a statement in there, which is nothing, and it falls into the next case. This allows us to do two things for the same set of values. So I want to print out 1, regardless of whether it's a +1 or a -1. And so I say case 1 followed by case minus 1. If it happens to be 1, it goes there, falls into the minus 1, goes and it prints out 1, then breaks, which causes it to go to the end. You want to make sure that you don't forget to put your breaks in where you want them, otherwise it'll fall into the next statement. When a switch goes in, it finds the first match, executes that, and then leaves. If it goes through all the cases and doesn't match any of them, it'll match the default and print out whatever it says there, which in this case is other. The default is optional. If it's not there and it doesn't match anything, it will do absolutely nothing. Okay, let's take a look at iterations. And we've got 3 different types of iterations we're going to look at. We're going to look at a while loop, which comes in, it asks the question, should I do the loop? If it's true, I do a sequence, I change some value, I go back up, I check to see if I should do the loop again. If so, I do it and keep doing that until the condition evaluates to false, which said I shouldn't do the loop anymore, at which point I go to the statement after the loop. A do while loop is different. It comes in and it starts to execute the sequence immediately. It changes something, then it checks a condition to see if it should continue to the loop. Then it goes back up and does the loop again. The while loop and the do while are very similar. The difference is where they do the check as to whether they should do the loop or not. The while loop does the check at the beginning of a loop. The do while does it at the end of a loop. One of the consequences of this is that a do while loop has to execute at least once because it doesn't check to see whether it should execute until it finishes going through the sequence at least once. The final loop is the for loop, and a for loop has a far more complex statement at the start of it. It does an initialization, it has a condition which it checks to see if it should continue the loop, and it's got a change which is executed when it hits the end of a loop. So it starts out, it initializes the loop, checks to see if it should do it, executes the body of the loop, does the change, come back up, checks to see if it should continue, executes the sequence, does the change, goes back up, and continues to do that until the condition becomes false, at which point it goes to a statement after the end of a for. So let's look at some real code now. Here's an example of a while loop, and we start out and we say n is 3, while n is greater than 0, printf the value of n, decrement n, and do that and continue to do it until n becomes 0 or less than 0. So every time through the loop, it's going to subtract 1 from n. It starts at 3, so it's going to go 3, then 2, then 1. The final time, it's going to subtract 1. It's going to become 0, then this will become false because 0 is not greater than 0, and it's going to go to the statement after the loop and print off blast off. So what it's actually going to print out is 3 the first time through the loop. It's going to decrement n to become 2. It'll print out 2 for the second time through the loop, decrement n to become 1. Then it will print out 1 the third time through the loop. It'll decrement n to become 0. It'll go to the top of the loop, realize that it shouldn't go through the loop again, go to the statement after the end, and print out the word blast off. The do while is very similar, except it does the test at the end. So we start at n off at 3, and it says do printf n, then decrement n while n is greater than 0. So it comes in and it says n is 3, so it prints out 3. It decrements it and it becomes 2. 2 is greater than 0, so it prints out 2, decrements it becomes 1. 1 is greater than 0, goes around, prints 1, decrements it becomes 0. Now suddenly 0 is not greater than 0, so it exits the loop and prints out blast off. Now the for loop has an initialization part, a colon, or a semicolon, a condition, a semicolon, and a change, all in parentheses. So I've got an integer n, and it says for n equals 3, and that n equals 3 gets executed once the very first time the loop begins. Every time it goes through the loop, at the start of the loop, it checks to see if n is greater than 0. And at the end of the loop, it does n minus minus after it's executed the body of the loop and before it goes around to check the condition again. So let's go through. And it says for n equals 3, n is greater than 0. 3 is greater than 0. We print out n, which is 3, which is up there. Then we decrement n, so it becomes 2. Is 2 greater than 0? Yes, it is. We print 2, decrement it, so it becomes 1. Is 1 greater than 0? Yes, it is. We print 1, decrement it, becomes 0. Is 0 greater than 0? No, it's not. So we come down here and print out the word blast off. 3 different ways of saying 3, 2, 1, blast off. Now, flags can be used when you've got more complicated logic. One of the things we were after was the ability to have a single entry point and a single exit point. So here we've got a while loop, and we decide inside whether we want the loop to continue or not. And I've got this, I'm going to read some numbers and I'm going to add them up. And I'm going to read them into a variable called n. I'm going to accumulate the sum in a variable called sum. And I'm going to use this keep reading to tell me whether I should keep reading or not. And the idea is they give me a bunch of numbers until they type a 0, and then we stop adding them up. So the way it's going to work, if you look at the output, is enter a number, 0 to stop, and they type 7. Enter a number, 0 to stop, they type 2. Enter a number, 0 to stop, and they type 0, and then we say the sum is 9. So if we go over here and look at the code, it says do printf, enter a number. Now it's going to do that without checking anything because this is a do while loop, so it goes in immediately. We use the scanf to read into the variable n, and then we set keep reading gets the value of n is not equal to 0. So that's either going to be a 0 or a 1. If it's not 0, it returns 1. If it is 0, then it returns 0. So it's true if it's not 0. So when we get a 0, that's going to become false. We add n onto sum because we don't have to check when and 0. It doesn't make any difference. Then down here, it says while keep reading is true. So when we do a while or any kind of condition, it's based on true or false. 0 is false, any other value is true in C. So because this guy is going to go to 0 if n becomes 0, then as soon as this becomes 0, it's going to exit the loop. When it exits the loop, it's going to print the sum, and that's it. So we're using this variable, which we set based upon a condition, inside to control when the loop terminates. Now that is a way of making sure, we could say, oh, if, n equals 0, then get out of the loop. But we don't want to do that. We want to have the loop have one exit point. And a flag allows us to set the variable flag and then have a check down at the bottom to see whether we should stay in the loop or exit. So we've got one entry point and one exit point with no other way out. And that's the property we want. And sometimes we have to use flags to make sure it works that way. Now we can place one if statement inside another, and this is called a nested if. So let's take a look. We've got a variable called n, which we set to be 4, and we've got another variable called even, and they're all ints. And we set even equal to if n mod 2 equals 0, which means if n mod 2 is 0, the remainder upon division by 2 is 0, which means it's even. So even becomes 1, otherwise it becomes odd. So I can say if n is greater than 0, and if it is, I go in here and I say if it's even, print out that it's positive even, else printf it's positive odd, because You couldn't get in here if it wasn't a positive number. Else, which goes with the outer if, printf, but it's 0 or negative, and I don't care whether it's positive or negative at that point. Or positive, even or odd, I just print out whether it's positive or negative. I can also nest loops, one inside another. And here's an example. I got a for loop. For I equals 0, I is less than 2, I plus plus. Inside, I set j equal to 2, and then while j is greater than 0, I print out the value of I and j, and I decrement j. So let's run through this. I come in here, and I is initially 0, and I go, if that's less than 2, I go here, I set j to be 2, j is greater than 0 is true, so I print f I and j, which is 0 and 2, which gives us our first line. I decrement j, so j is now 1. It's still greater than 0. I print out my value of 0 and 1 for I and j. I decrement j, so it becomes 0. It's not greater than 0 anymore. It goes to the end of that loop, and then it immediately hits the end of this loop, which causes it to go up to the start of there. It decrements I, so that it is now 1. Comes in here. 1 is still less than 2. It sets j to be 2. While j is greater than 0, it's 2, so it is. It prints out I and j, which should be 1 and 2. Decrements j to make it 1. Comes around, it's still greater than 0, so it prints out 1 and 1. Decrements j, it becomes 0. It's no longer greater than 0. It exits that loop. It comes around here. It decrements I for the outer loop, so it becomes, or it increments I, sorry. So it becomes 2. Then it comes up and says, is 2 less than 2? And the answer is no. So it exits the outer for loop, and that's where it stops printing. Okay, so that's how we can nest one statement inside another. Finally, we've got the dangling else problem. And when you get a piece of code like this with the indentation shown, you can have a problem. Does that else printf apply to this if or that if? Well, if you look at it, it's if followed by a statement, followed by an else, followed by a statement. This is followed by a single statement, and that single statement is an if, which has got an else. The general rule you follow is the else goes with the immediately preceding if. Now, if it had parentheses around or curly brackets around this if, it would be totally different. But this is called the dangling else problem, and you shouldn't have this because you should do your indentation correctly to avoid misinterpreting these things. So that ends my discussion of different kinds of structured programming. Thanks for listening.